What is going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to see how we can decompose this rational fraction, right? Now here we want to do the decomposition in R. So right, we want to do the decomposition in R, but we can also do the decomposition in C, and the decomposition is also going to look a bit different. So we'll start with decomposing our rational fraction F1. Right, we'll start by decomposing this in R, and then in another video we're going to look at how we can decompose this rational fraction in C. Now in R we have that. So here we have that our F1 is going to be equal to 6x squared plus 3x squared minus 5. Now this is going to be divided by, now this x to the power 4 minus 1 here can be written as x squared squared minus 1 squared. Now here you can clearly see that we have a difference of two squares here. So here we're going to have 6x squared plus 3x squared minus 5. Now this is going to be divided by x squared minus 1. And then here we'll have x squared plus 1, like so. Right? Now here, for the first one, we see that we also have the difference of two squares here. So we can also write our rational fraction as 6x squared plus 3x squared minus 5. Now this is going to be divided by x plus 1, and then here we're going to have x minus 1. Now the second quantity here, x squared plus 1, is not reducible in R, right? We cannot reduce it, as a product of two linear factors, because x squared is greater than or equal to 0, and then 1 is strictly greater than 0, and so the sum is going to be strictly greater than 0, and so this quantity is never 0, so it has no real roots, and so it cannot be written as a product of two linear factors. So we're going to leave it as it is. Now this is going to be considered as a quadratic expression. As we can see, we have the highest power of x here is 2, so it's a quadratic expression. So here we have 6x squared plus 3x squared minus 5 divided by x plus 1, x minus 1, x squared plus 1. Right, so it is here that our decomposition is going to start. Now this is going to be equal to, now I'll write this form of our F1 on the top, and then we can continue with our question. So we get rid of the top part like so, and then we rewrite our our F1. So our F1 is going to be equal to 6x squared plus 3x squared minus 5 divided by, here we have x plus 1, x minus 1, and then here we have x squared plus 1, like so, and then this is F1 is going to be equal to, and then we're going to get rid of the part here. Then we know that we're doing our decomposition in R. Now this is going to be equal to a certain scalar that we're going to call alpha 1. Now this is going to be divided by x plus 1, and then plus, this is plus, and then there's going to be another scalar alpha 2, then divided by the second quantity, which is x minus 1. Now here we have to be very careful because we have a quadratic expression, x squared plus 1, and the degree of the numerator now of what is going to be here has to be strictly less than the degree of the denominator. So this is going to give us we're going to find an alpha 3x plus an alpha 4, like so, and then this is going to be divided by x squared plus 1. So this is how the decomposition is going to look like. So we need to find the value of alpha 1 and the value of alpha 2. Now here we can easily find the value of alpha 1 and the value of alpha 2. So what we have to do if we want to find alpha 1, so what we want to do if we want to find alpha 1 is we can multiply x plus 1 throughout. Now multiplying x plus 1 throughout, for us to find alpha 1, we're going to multiply by x1. So let's multiply by x1. If we multiply by x1, we're going to get 6x squared plus 3x squared minus 5, like so. Then this is going to be, now we are multiplying by x plus 1, so this has to be x minus 1. Now this has to be x squared plus 1, like so. This is what we have here. Now this is going to be alpha 1 plus alpha 2 multiplied by x plus 1, and then here we have x minus 1, and then plus alpha 3x plus alpha 4. Now this is going to be multiplied by x plus 1, and then now this is going to be divided by x squared plus 1, like so. Now we're going to choose a simple value of x such that this quantity is going to be equal to 0. Now that value of x is going to be minus 1. Now we have to be careful here. our denominators don't have to be 0, and that is the case if we choose x is equal to -1. So if we choose x, here we're going to let x be equal to -1, and so here we're going to have that alpha 1 is going to be equal to, so here we substitute -1. So if we substitute -1 here, what are we going to get? So here we're going to get 6 multiply, we have -1 squared, which is 1. Now here we should have 6, and then here we'll have here we should have 6, right? So here we have a little problem here, because this is supposed to be x to the power 3 and not x to the power 2, right? So we correct that problem here. So this should give us a -6, because we know that -1 to the power 3 is going to be -6. Now this is going to be +3, and then this is going to be -5, like so. Then this is going to be at the bottom, we're going to have -2, and then here we're going to have 2, -2 multiplied by 2, multiplied by 3, sorry, because x squared -1 squared is 1, and then we'll have 2 here. So yeah, it's -2 multiplied by 2. So this is going to be multiplied by 2. Now this is going to be equal to, now here we shall have now -6 plus 3 is going to be -3, is going to be -3, and then -3 minus 5 is -8, and then -2 multiplied by 2 is going to be -4, and so alpha 1 is going to be equal to 2. So we get that alpha 1 is going to be equal to 2, right? So that is alpha 2. Now let's calculate alpha 3. So we're going to get rid of this bottom part, and then here we're going to say that alpha 1 is going to be equal to 2, right? So then we're going to calculate the next constant, which is alpha 2. So we're going to get rid of this part. Now we'll get rid of this part. Now we're going to multiply by x minus 1. We're going to multiply by x minus 1 throughout, and then we're going to choose a simple value of x such that the other quantities are going to go to 0, and we're going to remain with alpha 2 on the right hand side, right? So that we'll take here, we'll multiply by so to find alpha 2 we have to multiply. Now we have to multiply, so here we're going to call this entire thing, now here this entire thing in yellow, this entire thing here, we're going to call it, we can call it W, for example. We can call it W so that we don't have to rewrite, the entire thing. So this is going to be W. So we're going to multiply W by, we're going to multiply that by what? We're going to multiply that by x minus 1, by this x minus 1. And then we're going to choose x is equal to 1. And then the other quantities are going to be 0. So we're going to have alpha 1 is going to be equal to, now we substitute 1 on the left hand side. Here we should get 6, here we should get 3, and here we should get 5, like so. Now this is going to be divided by, now this is going to be 2, right? This is going to be 2. Now this quantity is going to, we're not going to have x minus 1 because we've multiplied by x minus 1, so it will divide here. So here we're going to have 2, and then multiplied by, now 1 squared is 1, so here we'll have 2 multiplied by 2. Now this is going to be equal to, now here we have that 6 plus 3 is going to be 9, and then 9 minus 5 is going to be 4, and then 4 divided by 4 is going to be 1. So we get that alpha 2, so here we have alpha 1 is equal to 2, and then alpha 2 is going to be equal to 1. Now we have to find alpha 3 and alpha 4. Now the technique that we're going to use here is going to be finding the limits of rational fractions at infinity. So we're going to find the limit. Now the first thing that we're going to do is that we're going to multiply the entire, this expression w, we're going to multiply this by x, right? We're going to multiply this by x. So here what are we going to have when we multiply this by x? So we'll multiply by x throughout. So here we should have 6x to the power 4 plus 3x to the power 3 minus 5x, like so. When we multiply by x, now this is going to be divided by, our denominator is x to the power 4 minus 1. Remember, I've taken the odd form. Now this is going to be equal to, now if we multiply by x here, we should have alpha 1x, like so, divided by x plus 1, like so, and then plus here we should have alpha 2x, and then divided by x minus 1. Now this is going to be plus, and then here we'll have alpha 3 x squared, like so, and then plus alpha 4x. Then this is going to be divided by x squared plus 1. Now here we've multiplied by x, right? we've multiplied by x. Then we're going to take the limit as x goes to infinity. So we're going to take x to infinity here. So when we take the limit as x goes to infinity, what are we going to have? Now, finding the limit as x goes to infinity of a rational fraction is very, very simple. Well, it is going, the limit of, the left hand side here is going to be the limit. Now, at the numerator here, we're going to get the monomial with the highest power of x. Now, the monomial with the highest power of x here is x to the power 4, and its coefficient is what? And its coefficient is x to the power 4. Now, this is going to be equal to the limit, now as x goes to infinity, of 6x to the power 4 divided by x to the power 4. That is how simple calculating limits of rational fractions as x goes to infinity is. Now, here we do the same. Now, here this is going to be the limit as x goes to infinity, because the limit of a sum is the limit of the individual terms in that particular sum. So here we should have alpha 1x. Now this is going to be divided by x, and then here plus the limit as x goes to infinity. Here we're going to have alpha 2 of x, and then divided by x minus 1, like so, divided by x, not x minus 1, because we've taken the monomial with the highest degree. So here we should have x, like so, and then plus the limit as alpha 3 of alpha 3x squared divided by x squared. Now here x is going to infinity, right? So here we're going to get rid of this middle part here. We'll keep our top part because that is where we're seeing our f1, right? Now the limit here, you simplify a little bit. Now as x goes to infinity, we're just going to have the constant 6. So this is going to be 6. Then this is going to be equal to, now here the x and the x simplify, so here we should have alpha 1. Now here the x and the x simplify, so here we should have alpha 2, like so. Now here the x squared and the x squared simplify, now here we should have alpha 3. Oh, we know that alpha 1 is equal to 2 and alpha 2 is equal to 1, like so. And then this is going to be plus alpha 3. Now here we'll get rid of the bottom part, like so. Now this is going to be 6. And then 2 plus 1 is 3. Now 6 minus 3 is going to be equal to alpha 3. Now 6 minus 3 is going to be equal to 3. So we found the value of alpha 3. Now we have to find the value of alpha 4. Now what has to be done here is very, very simple to find alpha 4. It's very, very simple. Now we're going to look at our f1 one more time, and we're going to make one observation. Now we know that this quantity is never 0 in R. It's never 0 in R, right? Because it has no roots in R. It is irreducible in R, right? The second one here, here we notice that when we take x is equal to 0, we'll have no problem here because the denominator here is non-zero, the denominator here is non-zero, the denominator here is non-zero. Even here, the denominator is going to be non-zero. So we can take x is equal to 0. So if we take x is equal to 0, here we're going to have if we take x is equal to 0, we're going to have minus 5 divided by, now this is going to be 1, now this is going to be minus 1, now this is going to be 1. So here we should get minus 1. Now this is going to be equal to, now here we've taken x is equal to 0, so we should find alpha 1. Here we should find minus alpha 2. Now here x is 0, so here we should have 1, and here we should have plus alpha 4, like so. Now this is going to be minus 5. Now alpha 1 is 2. Now alpha 2 is 1, so here we should have minus 1, and then here we should have alpha 4, like so. Now here we have a little problem. It is not minus 5, but it is going to be plus 5, right? Now here 2 minus 1 is going to be 1, so this is going to be 1 plus alpha 4, like so, right? And then now we find that alpha 4 is going to be equal to 4. Now here we found all our values, and so we're going to rewrite our f1. Now we having this decomposition, right? So here is having in mind this decomposition. So f1, which is going to be equal to 6x to the power 3 divided by x plus 1 and x minus 1, like so. And then here it is x squared plus 1, like so. And then this is going to be equal to, now alpha 1 is 2, so here we should have 2 divided by x plus 1. Now alpha 2 is 1, so here we should have 1 divided by x minus 1. Plus here, what is alpha 3? Now alpha 3 here is going to be 3x, and then alpha 4, we know that it is 4. Now this is going to be divided by x squared plus 1. Thank you guys for watching, and I'll see you in the next video.